This is Pre-Calculus B, Unit 5, Lesson 6. We are looking at the angle between vectors. And this unit is dominated by one formula. If I have two vectors, let's go ahead and give an example here. Let's say we have this vector, which is 2, 5. Okay, so vector u equals 2, 5. And vector p, or v, is 4, 3. 4, 3. No, that's 5, 3. Let's do 4, 3. 4, 3. Vector v is 4, 3. Or you could express it as 4i plus 3j. Okay, so we've got these two vectors. Let's go ahead and draw them. And we're interested in finding the angle between the two vectors. I'm not going to derive the formula. I've played around with deriving it, but the mathematics is very long. It would fill a couple pages, and so I don't want to take the time to do that here. But here are our two vectors, and we're interested in the angle theta between them. Okay, and here's the rule, the formula that you need to memorize. Cosine of the angle theta is u dot v, so the dot product of u and v, which is a scalar, a number, not a vector, divided by the magnitude of u, which is a scalar, times the magnitude of v, which is also a scalar. Okay, and the answer is in radians. So be aware that we're talking about radian measure. If you need to convert to degrees, you need to multiply by 180 over pi, right, to convert radians to degrees. Divide by 1 or multiply by pi over 180 if you're having degrees and need to convert to radians. So that's useful to know. Okay, and so there we have the formula, and let's take a specific example. Okay, let's take this example here. So we're going to say cosine of theta is u dot v. So let's figure out u dot v. U dot v is 2 times 4 plus 5 times 3, which is 8 plus 15, which is 23. Okay, so 23 on the top. On the bottom, the magnitude of u, it's basically the Pythagorean theorem, so is the square root of 2 squared plus 5 squared, which is the square root of 4 plus 25, which is square root 29. Okay, and the magnitude of v, which is 4 squared plus 3 squared, square root, which is 16 plus 9, which is the square root of 25, which actually turns out to be exactly 5. Okay, and so now we can find the angle by taking the arc cosine. So theta is approximately, and the sketch is always good, because remember, there we need to be aware of whether the angle is obtuse or greater than 180, etc. All right, so let's go to Desmos. Oh, Desmos! Here we go, Desmos, not Desleast. Okay, so we're going to take the arc cosine 23 divided by square 5. I'm going to do 5 square root 29. Okay, 0.5468. 0.54 radians. If we want to convert that to degrees, let me do this here. So this is theta. I'm going to call it t, because if I call it theta, that's a system variable in Desmos. It gives me problems. Okay, I'm going to do t times 180 over pi. So about 31.33 degrees. Okay, and that seems to mesh with what I'm seeing here because I did do a proper graph here. So that's approximately 31 degrees. Okay, and that meshes with reality. Now, if you find, and this is the second application. The first application of this formula is to find the angle. The second application is to tell if angles are parallel or vectors are parallel, perpendicular, or neither. They are parallel if theta is 0. They are perpendicular if theta is 90. They are neither if in neither of the cases theta does not equal 0 or 90. Okay, it's a little bit easier to think of it this way. When theta is 0, cosine of 0 is 1, right? Cosine of 0 is 1, and so basically the formula u dot v over magnitude of u, magnitude of v is going to come to 1, right? And I already mentioned this. If u dot v is 0, if the numerator is 0, then the cosine of 90 degrees is 0, and the angles are perpendicular. So, and then of course neither. Now, and they are also parallel if theta is 180. Okay, or if this u dot v over u magnitude of v equals -1. So if it equals 1, if this equals 1, u dot v over magnitude u magnitude v equals -1 or 1, then it's parallel. If it's equal to 0, it's perpendicular. Okay, so that's generally the rule. All right. I'm going to save the next example for another video because it's fairly involved, but that's the concept of figuring out work. So I'm going to leave this for another video.